This is an amazing problem on equations. I want all of you to watch this video right till the end, and here we go. Very, very interesting case. Please watch. Find the number and position of real roots of, that's the equation. Okay. You need to find the number, how many, and position, where, of real roots of this equation. Let me rewrite this equation. What we are going to do is an investigation. We are going to do positive of x, and when you do that, no changes in sign up here. Wonderful. So this is positive, positive, negative, and negative. Let me write all of them. Just count the changes in sign from positive to negative or from negative to positive. Sir, in that case, there would be only one change here, right at the middle, from positive to negative. And this essentially indicates that f of x cannot have more than one positive root. Listen to the statement again. F of x cannot have more than one positive root. Okay, that's what we've written. Max. This is the max value. Okay. What about f of minus x? Let's do that. Odd powers will be subjected to change in sign. This is going to become negative, whereas this negative 4x here would become positive. Done, sir. Just work out the signs. Plus, minus, write them down. How many changes can you encounter? Sir, plus 2 minus, change number 1. Minus 2 plus, change number 2. Plus 2 minus again, change number 3. There are as many as 3 changes. So you can conclude that f of x cannot have more than 3 negative roots. Okay, 3 is the maximum value it can have. It won't go more than 3, rather it could be less than 3. Now, the first thing is over, the number. The second thing is position of real roots. Where do they exactly position themselves on the real number line? To work it out. How can you do that? Let me explain something. There is a property that we learned in our first lecture. Where is that? Here we go. So try to read this. If f of a and f of b have different signs, then the equation f of x is equal to 0 has at least one root between x is equal to a and x is equal to b. Let's say you put the value of x as a. The corresponding value of function is f of a. But what we observe is that this is a negative value, isn't it? Then we put the value of x is equal to b. We observe that we've got a positive value. Then the property says that it has at least one root. Here is that root. At least one root between x is equal to a and x is equal to b. And it is this property which we'll be implementing to find the exact position of the root. Okay, here we go. Sir, but how do we know a and b? In that case, please follow this rule. Always change the value of x from minus 5 to positive 5 in steps of 1. That means what you need to do is you need to put the value of x is equal to minus 5 and get the value of f of x. Then put the value of x is equal to minus 4, then get the value of f of x. Okay, so a lot of calculation has to be done. But sir, this is going to take a lot of time. You have a calculator, don't you? Use it. You have invested almost $1,000 on your calculator. Use it. Hit on mode. Hit 7 for table. F of x. Write down your equation. Sir, our equation is x to the power. Oh, okay. Minus. Not minus, sir. This is actually, how can I delete this? Plus 4 x cube. What else? Minus. No. Minus 4 x. What else? Minus 13. So this is your function. Okay. Equal to sign. G of x. There is no another. You don't have any other function. You need to start from negative 5. Done. You need to end at positive 5 plus 5. Done. What is the step? Step of 1. Enter. These are the values of x from minus 5. Step of 1, that is plus 1 will give you minus 4, then plus 1 will give you minus 3. So corresponding to minus 5, you've got the value as 132. For minus 4, you've got the value as 3. And you can see we've got all the values from minus 1, 0, 1, 2, 3, 4, 5. So you need to copy down all of these things. I've already done that over here. Let me show this to you. Okay. Now you need to observe for which values of x there is a change in sign of f of x. Sir, for -5 it is 132. Sir, it is positive. For -4 it is 3. Sir, this is also positive, no change. Sir, but sir, what we can really observe is here automatically from a positive 3 we get -28. That means there has to be one root between -4 and -3, and this is how you can work out the positioning of roots. Okay, so what we can do is, as f of x has changed sign from positive to negative, we can say that one of our roots is between -4 and -3. Which root? Which kind of a root? Sir, it is a negative root since it lies between -4 and -3. Done. The second thing is, if you watch, keep on observing, -21, then -12, -13, -12, all of a sudden you get a positive value of function. From -12 to +27, between 1 and 2. Sir, between 1 and 2 also we are going to have another root, so obviously a positive root. Okay, so position of the second root is between x equals 1 and x equals 2. The problem is over here. But sir, why should we believe you? Can you really show us graphically all of these things are for real? Okay, you have used your pen and written down all of these things. Until and unless we don't see in a graph, we are not going to believe you. Okay, the technology is there for all of us to observe. Watch. So I've written down the function. Let me show that to you. Here it is. And this is the plot. X to the power 4 plus 4x cube minus 4x minus 13 equals to 0. That's your function, right? One root is between, sir, -4 and -3, while the other root is in between +1 and +2. Remember, -4, -3 and +1, +2. Let us deal with -4 and -3 first of all. Where is -4? Sir, here it is. As you all know, wherever the graph of this function cuts the x-axis, that is exactly the position of your root. You can clearly see that the graph cuts the x-axis at two positions. One to the left of 0, one to the right of 0. That means there are going to be two roots. One positive roots, that is to the right of 0, and one negative root. And that negative root happens to be between -4, very close to -4. -4 and -3. So this is true, sir. Okay. Secondly, if you watch, and there is also one more root, sir, between 1 and 2. You can clearly see this. Now do you believe me? I hope you do. Thank you very, very much. Do share this video and do share this channel with all your friends and classmates so that they can also benefit. Thank you very much. This is Manas Patnaik signing off. Take care. Have a nice day.